What's up, guys? Welcome to Nullvoid. Today we're going to go over a problem called container with most water. It's a problem being asked by companies like Microsoft, Facebook, Amazon, Google. So let's look into it. The problem description says that given n non-negative integers a1, a2 till an, where each represents a point at coordinate I, ai, n vertical lines are drawn such that the two endpoints of the line is at I, ai and I, 0. Find two lines which together with the x-axis forms a container such that the container contains the most water. And there is a note that you may not slant the container. I am not sure why will you do that. Let's solve this problem. We'll take this example to understand what the description wants to say. We have this height array. In this height array, each element represents the height of the vertical line that we are seeing. And we need to, what basically we need to do is we need to find the rectangle with maximum area, and they are calling it a container. The rectangle with maximum area will be in this case will be made with the second vertical line and the last vertical line, and their area will be, so their length will be 8 minus 1, 8 being the index of the right bar, 1 being the index of the left bar. 8 minus 1 will be length, and the breadth will be 7, basically the height of the right bar. And why we are taking 7 and not 8? Because we do not want the water to overflow, and we need to find the container that can contain most water. That is why we'll take 7, not 8, and the area will come out as 49. And if you solve this, that will be the maximum area that will be contained here in this example, and that is represented by this blue section, that is water. So let's try to understand this problem better by the hint that they have given us. There's a very good diagram that they have mentioned it. First, we should understand what will be the brute force way of solving it. Brute force way will be, we'll pick each element and try to calculate area with all other elements. We can fix 0th element and calculate area with the first element and second element, and on and on. And in the end, we'll know what we'll use a max area variable, and we'll know that's the maximum area. So in this hint, they have given this diagram. What we will do is we'll take one pointer. We'll take two pointers. One will be at the start of the array. Another will be at the end of the array. In this case, our first pointer will be at the bar representing 3 height, and the second will be at the last end of the array, that will be the bar with height equals to 6, and their area will be 7 into 3, 7 being their horizontal distance, that is the length, and 3 because 3 is less than 6, so 7 into 3, the area will come out as 21. Next, what we will do is we know that 3 is less than 6. So if we increment our left pointer by 1, we'll reach at the 1th index bar that has height 9. Now we'll calculate the area. The area will come out as, now the length has decreased from 7 to 6 because we have moved by 1 point, and height, the smaller height is 6. So 6 into 6 will become 36. That is greater than 21. So we will take this as the maximum area, and we'll start calculate the area again. So now we know that 6 is less than 9, so we will decrement our right pointer. It will come at this bar with height equals to 12. We'll try to calculate the area. Length has again decreased by 1, so length is 5, and breadth is 9 because 9 is less than 12. Our area will come out as 45. Now let's start solving it. Let's first initialize our variables. We need a max area variable that will contain our the final response, and we need an area variable. I think we can create this variable in our while loop that we will use to iterate it. Let's remove this. Let's remove this. What else we need? We need our pointers. So we can say the left pointer is I equals to 0, and the right pointer will be at the end of the array. So it will be j equals to height dot length minus 1. So that will come at the end of our array. That's good. It should be height, not right. Okay. So I think that's all we need. Let's start iterating, and our condition will be I less than j, because we do not want them to intersect. We'll know that we have calculated all the area when we reach at their intersection point, and we need to create our area variable that will contain our current area, and our if condition will be to check which one of the bar height is smaller. So we will do if height of I is less than height of j, that is our left bar is smaller, uh, or our right bar is smaller, that will come in the else condition. Here we'll calculate the area. For the area, the length will be j minus I, because j is our the rightmost index and I is our leftmost index. If we look at this example, yep. So in this example, the right bar was at index j was 7 and I was 1. So 8 minus 1 became 7. So that is the length between those bars. So length is j minus I and breadth will be height of I. Why height of I? Because we already know that height of I is less than height of j. So that will be our current area. And what should we do next? We should increment our ith pointer. If this is not true, then we can calculate the area again in the same manner. Length will be j minus I, and height will become height of j, because height of j is smaller than height of I, as we are in the else condition. And we should increment the ith pointer. When this is done, we need to compare if our current area is greater than max area. If that is so, we need to update our max area. So what we can do is we can do math.max of our current max area and our current area that we have calculated just now in this for loop, not for loop, while loop. Yep. So this will update the max area in case area is greater than max area. I think this is good. Now we should just return max area and we are done here. That should be good enough. So this should work. Let's see if we have any problems in this. We missed a semicolon here and here also. And also this should be j minus minus, because we are decrementing our right pointer. If you do not do this, if you do j plus plus, it will give you array index out of bound. And let's run it. This should work. Yep, it works. Let's submit it. It passed all the test cases. The runtime is 2 ms. It is faster than 98.42% of Java online submission for container with most voter. The time complexity is O of n. So that is how you solve this problem. If you have any doubt or if you want me to solve any other coding problem, you can comment that below and I can take a look. And if you found this helpful, then please do leave a like and subscribe to my YouTube channel. I'll bring a lot of such videos. And I think that's all from my side for this time. I'll see you next time.